Good morning, students. So, welcome to the module 18 of the supply chain management subject. Right. So, today we are going to discuss the models for the facility locations and the capacity allocations. Right. So, before entering this, just we can recap what are the terms we discussed in last class. Right. So, for the last class, we discussed what is the network design decisions, right? What are the network design decisions are there? We have four network design decisions. So the facility location, capacity allocation, supply and demand allocation, that is a marketing allocations, and the role of the facility, right? So these four are the important decisions, right? These four have to consider important design decisions, right? Then what are the factors which influence the design decision while designing the network design decisions, right? So strategic factor, technological factor, microeconomic factor, political factor, infrastructure factor, competitive factor. These are the factors, and we, in this factor we have added a cost also, the facility and the logistics cost, facility and the logistics cost. So these are the factors, these are the factors which influence the network design decisions. Then, so last class is discussed the framework for the network design decisions, right? So here we have four phases, right? So the first phase will give the definitions, right? The basics about the supply chain strategy or a design, and the second phase, and the second phase it will give the define the regional locations, right? Regional facility configurations. Then the third phase will be the potential desirable potential sites, and for the fourth phase the location choices, right? So this is the framework for the network design decisions, right? So in this phase one we may see the competitive strategy, that is the business strategies, the internal constraints, and the global competitions, right? So that term will be in the phase one, right? Then for the phase two, for the regional facility configurations, regional facility configurations. So here we have to see the six terms, right? So what are the terms? So one is the taxes, right? So how the tax and tariffs will be there in the particular location, particular region, right? Then what about the region's demand? The region's demand or the surrounding of the region demand. And what about the political stability and the exchange rate and the risks are there in the particular region, right? Then the what are the production technologies will be there, what are the facilities will be available there, right? Then how the competitive environment will be there, right? Then the factors, right? Aggregate factors of the logistics, transportations, right? So how the facilities are there for the logistics in the point of view, right? So in the regional facility configuration, we have to see the six terms, right? Then the third phase, the desirable sites, right? So in this desirable sites, we have to see the production methods, right? We have to see the production methods and the infrastructure availability right? So here the infrastructure availability will be classified into two terms. One is the hard infrastructure and one more is the soft infrastructure builds, right? So that we have to see for the desired potential sites. Then the fourth phase will be the location choices, right? So how, what are the factors we have to see for choosing the locations? Then one more, the transportation cost, that is a logistics cost, right? So what are the costs will be involved in the logistics cost, right? So whether we have to choose the location, right? Whether it will be having facilities, that is a factor cost, right? So labors, materials, and the some other site specifications, right? That and all will be here or not, that we have to see. And we have to see the logistics cost, right? So these are the framework for the network design decisions that we discussed in last class. So now in this class we are going to see the models, right? The models for the facility allocations, facility locations, and the capacity allocations, right? So these two are the important design decisions, right? So in the design decision, we have four design decisions, right? What are that? The facility location, capacity allocation, and the market supply demand, and for the role of the facility, right? So in these four, so here we can see the two, the facility location and the capacity allocation. So these are the more important one, right? These are the more important one, right? So when the manager's goal, right? So a manager's goal when the locating the facilities and the allocating of the capacity, it should be to maximize the overall profitability. It maximizes the overall profitability, and that's the first point. See, the overall to maximize the overall profitability, right? Then due to this overall profitability, it results the supply chain network while providing the customers with the appropriate responsiveness, and the revenues comes from the sales of the product, whereas the cost arises from the facilities, labors, and the transportations, materials, and inventories, right? So these will be included, right? So these costs will be we have to add, right? So when making the revenue of the product, so we have to consider the cost rises from these terms, that is the facilities, labors, transportations, materials, and the inventory, right? So these we have to see, right? Then the profit of the firm is also affected by the taxes and some tariffs, right? So in ideally what we have to do, or what the companies are do, means the profits after the taxes and the tariff, it should be maximized. So depending upon that factor, while making the design, while creating the design, the profit has to be maximized after the taxes and the tariffs, right? So while designing, we have to consider that factor is very important one, right? So how we can improve the profitability, right? How we can improve the profitability of the firm, right, after the taxes and the tariffs, right? Then the managers must be considered the managers must consider the many of the trade-offs during the network design, right? So for example, building a many facilities, right? Creating the many facilities to serve the local markets, it will reduces the transportation cost, and it will provide the fast customers response, right? It will provide the fast response to the customers, fast response time. But at the same time, if we increase the facilities, the inventory cost it may increases, and the facility cost also it may increases, right? So that we have to see. Then the managers uses the network design models in two situations, right? So what are the two situations, right? The first one is the model used to decide the location where the facilities will be established and the capacity to be assigned to each facility, right? So that we have to see. That's the first situation. And the second situation will be the models are used to assign the current demand to available facility and identify the lanes along with the products will be transported. It will be transported, right? So the managers must consider this decision at least on the annual basis of demand, price, exchange rate, and the tariff changes, right? So in the both cases, that both situations, the goal is to maximize the profit, right? So the two situations, right? So whatever maybe the first one or the second one, right? So the goal is to maximize the profit while satisfying the customer's need, right? So we need some informations, or the information has to be collected while making the design decisions, right? What are the information which has to be collected, right? So these information is ideally available in the making of the design decisions, right? So what are there? You can see one by one. So the local supply, the location supply, sources, and the markets, right? So how the supply sources will be there, how the market will be there in a particular location. Then the locations, facility sites, the location of the potential facility sites, and the demand, right? So we have to forecast the demand by the market, and we have to see some cost, right? So how the product cost will be increases, what are the costs will be arises from the terms, right? So that terms will be the facility, labor, and the material cost by the site. Then so the distribution, right? So the distribution is a one important one in all a supply chain management. So in the distribution, the transportation, the distribution is occurring the every pair of the stages. Every pair of the stages, we have some distribution. So and the type the distribution, that surely the transportation will be there. So the transportation cost between the each stages or each pair of the stages, right? So that we have to see. Then the inventory cost by the sites as the function of the quantity, right? So the inventory, what is the inventory? We have to store the materials in a particular facility, so the inventory will be more, right? So the inventory cost by the location, right? So that information has to consider. Then the selling price of the product is different from the different regions, right? So if I buy a product in a particular place, so there the taxes and tariff will be somewhat less, right? So while comparing to other places, so the selling price, right? So even the petrol, right? Even you can see the petrol, the even the district wise the petrol maybe changes, right? The petrol price will be changes. So the different selling price will be there in the different regions, right? So the due to the tariff taxes and the tariffs, right? So due to this the sales difference will be there, and the response time and the factors, right? So what is the response time and what are the factors will be there, right? So that information has to take, right? So these informations, right, these informations are available, or it may be correct while doing the design decisions, right? While making the design decisions, we have to see these these information we have to consider, right? So given this information, so either the gravity model or a network optimization models that can be used to design the network, right? So we have two models. So one is a gravity model and one more is the network optimization models, right? So we can see the network optimization model, right? We can see the network optimization models, right? So what is the network optimization model, right? So in the framework, we have the second phase. What is the second phase? It is the regional facility configuration, right? It is the regional facility configuration, right? So in that network framework, the second phase, regional facility configuration, the managers considered the regional demand, tariff, then the economic scales, right? So the regional demands, tariffs, and the economics of the scales, and some aggregate factors of cash. That is the aggregate means what is that? So here the facility, right, where the facility will be there, right? So where the location will be there, right? So on that location, what are the capacity of to hold the products, right? So that is the aggregate factor cost. That is the inventory cost, right? The inventory cost to decide whether the region is suitable or not, right? So whether the location will be suitable in a particular region or not, that we have to see, right? So the inventory cost is a very important one here, right? So the inventory cost, the inventory will be changes depending upon the demand and the economics of the scale. It may, yes, yes. Do you have any doubt? No. So shall I proceed? Great. Fine. So the advantage, right? The advantage of this type of the approach, the advantage of this type of approach. So if we are placing the facility, if you are placing the facility to the nearby the customers, right? Anyone having doubt? No, no. So some disturbance will be there. Vibilishini, uh, mute your mic. Great. So the advantage of the approach is to lower the transportation cost, right? So how we have to optimize the network design means we have to reach the customers. The customers has to use our facility in easy manner, right? So while in the the customer has to reach the facility in easy manner, right? So there the transportation cost will be low, right? So there the transportation cost will be low. At the same time, uh, the customer reach the product in a very fast manner, right? So it may avoid some duties. It will helps to avoid some duties, right? So this is the advantage. And for the disadvantage, if the facility will be created in a lot of places, right? So there the capacity also we can increase means surely it will increases the cost. Surely it will increases the cost. So it will be affects the economic of the scale, right? It will affect the economic of the scale, right? So that we have to see, right? That we have to see, right? um, for optimizing the network design decisions, right? So we have to collect the data, right? So here the examples, right? Here you can see the supply regions, right? What are the supply regions are there, and what are the production rates are there, right? What are the production rates, right? So like that we have to collect the data, right? So in a particular region, right, what about the production rate, right? So that data we have to collect first, right? Then here we have a model, that is the capacitor plant location model. Capacitor plant location model, right? It is one of the network optimization model, right? It is one of the network optimization model. See the capacitor location model, right? Capacitor plant location model, right? So in this model, so we need some inputs, right? We need some inputs, and we need some the desirable variables, right? So we need some the variables, right? So here what are the inputs we have needed to do the designing or to do the optimization, right? So these are the inputs, right? So these are the inputs, right? So which is represented by n is the number of potential plant location or the capacity, and m will be the market and the demand points, and dj is the annual demand of for the market j, and ki it is the potential capacity of the plant I. Then the fi, which is the important one, fi is the annualized fixed cost, right? Annualized fixed cost, right? So here we have two types of costs are there, right? One is the fixed cost and one more is the variable cost, right? So always the fixed cost will not create the more impact, right? It will not create the more impact. Why? Because it is a fixed one, right? But the variable cost, it will impact more on the capacity allocation. It will be more on the capacity allocation. So why? Because if the number of capacity, if the number of sizes will be increases, so the variable cost will be increases. The variable cost will be increases, right? So our ultimate aim is to minimize the transportation cost, right? We have to give the product to the customers, right? We have to give the product to the customers at lowest price, right? So how we can reduce our price means we have to manage our supply chain demands, right? So supply chain costs, right? So generally the designs, right, whatever may be the design, so the design will be evaluated by the two terms, right? One is the value provided to the customers, and second one is what is the cost will meet the customers, right? That is the supply chain cost, right? So if we are reducing the supply chain cost, so what will happen? So the customers may get some benefits, right? The customers may get some benefit, so they will happy, the customer experience will be good. So we have to reduce the cost, the supply chain cost, right? We have to reduce the supply chain cost. So for that only the fixed cost and the variable cost, that is the total cost of the product, right? So the variable cost will be varies, the variable cost will be varies. It will be create more impact on the capacity size, right? It will be impact on the capacity size, right? So here the annual fixed cost, right? Here the fi is the annually fixed cost. So these are the inputs, right? These are the inputs. And so, and here we have some variables also. Here we have some variables, that is the yi, right? Yi is equal to 1 if the plant I is open, the new facility will be open, otherwise it will be a 0, right? Otherwise it will be a 0. At the same time, the xij, it is the quantity shipped from the plant I to the market J, right? So I is the facility, the plant, and J is the market, right? So what are the size of the materials will be shipped? The quantity shipped from the plant to the market, that is xij, xij. So here we have some input and some desirable variables, right? So these are the inputs, right? These are the inputs, right? And these two are the desired variables. These two are the desired variables, right? Is it clear? So the supply chain terms, right? In the supply chain terms, the goal is to decide the network design decisions to maximize the profit, to maximize the profit after the tax. After the tax, we have to create the maximum profitability, right? So at the same time, the customers make the product at lowest price. So we have to minimize the transportation cost. We have to minimize the supply chain cost to the customers, right? So here I can take an objective function, right? Here I can take an objective function, right? So here I can mention the minimize. So I have to minimize the cost, right? So it is the mixed integrate program, right? So mixed integer program, right? So in this program, we have to minimize the cost, right? We have to minimize the cost. So here these two are the costs. These two are the costs. So what are the costs will be there, right? So here you can see the fi and fy, fi and yi. It is a fixed cost, right? It is the fixed cost, and the fixed cost will be summation of to the variable cost, right? So that variable cost is depending upon the quantities, right? So variable cost will be create the more impact. The variable cost will create the more impact on the supply chain cost, right? So if the quantity will be high, surely the variable cost will be increases. So here you can see the xij, right? What is that xij? It is a desirable variable. So the quantity to be shipped from the plant to the market, the size, right? So then Cij is the cost of the producing and the shipping of the product to the plant to the market or plant to the customers, right? So which includes the supply chain cost, the distribution costs, right? So what is the distribution? Distribution is a stepwise process to move or hold the product, the one stage to the other stage. That is, the one stage means the manufacturer stages to the customer stages, right? So that will includes, see here the production cost is there, then the inventory cost, transportation cost, and the tariffs, right? So here the cost of production will not reduces, right? So every product will have some values, right? So we have to reduce these costs, right? We have to reduce these costs, right? So this term is called the variable cost. This term will be called as the variable cost, right? So here I have an objective integer, right? In this integer we have to reduce the transportation cost, we have to reduce the supply chain cost. So I using the minimize, right? I using the minimize, right? So if I minimize this transportation cost, so obviously it will maximize the profit of the firms, right? It will increase the profit of the firms, right? So every program, right? So every integer, it will be subjected to some constraints, right? It will be subjected to some constraints, right? So here I can give the three constraints, right? So what are the constraints, right? So main objective function is to minimize the total cost, right? The main objective function is to minimize the total cost, right? In this total cost we have the two costs. So one is the fixed cost, right? So it is the fixed cost, and it is the variable cost, right? So summation of these two is a total cost, right? So our objective function is to minimize the total cost, right? We have to minimize the total cost, right? Here we have the three constraints, right? So whatever may be the integer, it will be subject to some constraints, right? So first constraint we can see, right? The first constraint will be the demand at each location or a regional market, it will be satisfied. So the first one, right? So the J term, right? So what is the DJ? We have to fulfill the demand, right? Here DJ, right? So what is DJ? So DJ is the annual demand from the market, right? Annual demand from the market. So we have to fulfill the customers, right? We have to fulfill the customers demand at each regional locations, right? So that is the first constraint. That is the first constraint, right? So here the J value will be 1 to M, right? See here the J value will be 1 to M. So what is the M? M is the number of markets or a demand points. Then the second constraint is that no plant can supply the more than its capacity, right? So the K factor, that is a potential capacity of the plant, right? So the demand has to supply in correct manner, right? So the excess capacity will not be there, right? That will be the constraint 2, right? The K, right? So the Ki is the potential capacity. So the potential capacity for the plant, that is Yi, right? So the number of plants per the capacity, it will not exceed the maximum value, right? It will not exceed the maximum value, right? That is the second constraint. And the third constraint, right? So the third constraint is to enforce that plants is to be either it will be open, right? It will be open. That is, see here the Yi, right? If we will place a 1, right? So the plant is opening. Otherwise, the 0, the plant will not open, right? So you can see the enforce that the each plant is either open or it may be a closed one, right? So the Y value, the Yi will be either 1 or a 0, right? So the Yi, so either 1 or a 0, right? So these are the data will be needed, right? So then we have to optimize the program, right? We have to optimize this program, right? So it is the one of the model. It is one type of model which will be used for the network optimization design, right? So here I can say one example, right? So how the data will be collected and how it will be there, that you can see for the example, right? So here I can take a particular product, right? What may be the product, right? So XYZ, right? So here how the input data will be there means, so we have to see the regions, right? So for example here I have taken the 5 regions, right? So what is that? 1, 2, 3, 4, 5, right? So these 5 are the regions. These 5 are the regions, and the each region, right? Each region. What about the production cost? What about the demand, right? So here, all the cost will be denoted by the $1,000, right? So for example, here the 81 means the $81, $81,000, right? $81,000, right? So what it indicates, what it 81 indicates means the production and the transportation cost for the 1 million product, right? So the production cost, that is the demand region, right? The demand region will be for the 1 million, right? So for example the first one, we can see the first one, right? So if the product will be producing from this particular region, that is the North America region, right? So the product will be producing in North America, then it will be sales, right? So where it will be sales, right? So it will be sales in North America means the cost will be somewhat less. Why? Because the transportation cost is very low, right? So the transportation cost is very low. But if it will be sales in South America, but it will be sales in another region. So what will happen? So gradually it will be increases its price, right? So at the same time, at the other areas, other regions, right? So depending upon the distance, the price may be varies, right? So the selling price may be varies for a particular demand of the product, right? So for the 1 million products, right, the 1 million products will be produced from the first region, that is the North America region. It will be sales, right? It will be sales at the other regions, that is South America, Europe, and Asia, African, other regions, right? So it cost will be surely varies, right? It cost will be surely varies, right? So the sales, right? So here the sales up to this, right? So the costs, right? The variable costs will be there, right? So these are the variable costs, right? These are the variable costs are there, right? Then the demand, the annual demand. So here the annual demand also there, right? Here the annual demand, the region wise, right? So if the North America region, so the annual demand will be the 12 million, right? The annual demand will be 12 million units. And for the South America, right? So it will be 8 million units, right? So the demand and the region will be in this matrix, right? Then what about the fixed cost? What about the fixed cost, right? So here we have the two types of costs, right? One is the fixed cost and one more is the variable cost, right? So it is the data collection. It is the data collection. So fixed cost, right? So to creating the demand of the particular product, right? So what will be the fixed cost, right? The fixed cost will be allocated. See, here the fixed cost will be allocated, right? So in this fixed cost, it will be allocated by the capacity. For the low capacity, so what about the fixed cost, right? So you can see, so every region I fixed as the low capacity, right? So that low capacity, in that low capacity we have to fix the cost, right? So the fixed cost will not vary. The fixed cost will not vary, as well as the variable cost, it will be varies, right? The fixed cost will not create a more impact on the minimizing the transportation cost, minimizing the transportation cost, but the variable cost will be create the more impact. It will create the more impact, right? So if the plant capacity will be increases, if the plant's capacity will be increases to the doubled one, right? So here the high capacity is there. See, so first I taken the low capacity. For the low capacity, how the fixed cost will be there, right? But it increases the capacity. It will increase the capacity. At the time also the fixed cost will be increases. Here the plant capacity is doubled. See, here I can take the plant capacity 10 and here I can take the plant capacity is 20. So the capacity will be doubled, but the fixed cost will not double. See, here I can take 6,000, but here I can take only the 9,000. So the fixed cost will not twice as the capacity will increases, right? So it will get some reduced cost. The fixed cost will be reducing while increasing the capacity. While increasing the capacity, the fixed cost will be reduces, right? So if the capacity will be doubled here, so the fixed cost will be increases by 1.5, right? So it will be increases in the terms of the 1.5. If the capacity will be increases the thrice, so it will be equals to 1.2, right? So like that the fixed cost will be a marginal one, right? But which one is variable? So depending upon the decision variables, right? So here I can set all the values will be 0. See, here I can set all the values will be 0, right? So why I have to uh, give that values will be 0 means, so here you can see what about the desirable variables, right? So the desirable variables will be these two, right? So whether the plant will be open or closed, and what are the amount, right? What are the quantity will be shipped from the plant, right? If the plant will be open, then surely the product will be comes out to the market, right? If the plant will be closed, at the time the it will not create any quantity to ship from the plant, right? So these uh, right. So the model, right? So here you can see the different type of cells, right? So here you can see the different type of cells, right? So first, here, right? So from here, right? So from here to here, uh, it is F8, okay, right? F8, F18, right? So these values, right? So these values correspond to the various decision variables depending upon the x, I, j, right? X, I, j, right? So if the plant will be open, right? So at the time, a particular amount of the particular size of the product will be shipped to the market, right? That particular product will be shipped to the market, right? That values will be we have to enter, right? That value should be we have to enter here, right? Then the second, right, if the plant will be open for the low capacity and if the plant will be open for the high capacity product, right? So due to the low capacity and the high capacity, surely the fixed cost may be varies. Surely the fixed cost may be varies, right? So here I have to indicate whether it will be open for the low capacity means I have to put 1 for the particular region, right? A particular region you have to mark as a 1, right? So if you are using the high capacity means, so for the low capacity I put 0 and for the high capacity I will put 1, right? So like that I have to create this data collection, right? So I have to give some data to the from the data collection. What are the demand variables will be there, right? So what are the inputs are there, and what about the desired decision variables are there, right? So that we have to see, right? So by using this, we have to compiler by using the Excel sheet, or we have to manually calculate the optimization model, right? So we have to calculate the linear programming, right? So then we can get some cost values, then we can get some cost values, right? So if I have any time means I will create a Excel sheet and I will using by the solver add-on tool, and I can explain in the last class, right? I can explain in the after the syllabus is completion. If I have time means I can explain this type of examples, right? This type of examples. So now we can see then what is the capacity model location, what are the optimization objectives will be used here, that you can see, and what are the constraints are there, that you can see. That's enough for your syllabus. But if you have to know more about this optimization location models means I have explained after the syllabus is completion. Surely we have some time, right? On the time I can use the Excel solver and I can I can manipulate the values and I can give the examples to you, right? So up to this, the second unit will be over, right? Up to this, the second unit will be over, right? So what are the terms we have discussed in the unit 2, right? So the unit 2 will be in the two phases. The unit 2 will be in the two phases, right? So what are the phases? First phase will be depending upon the distributions, right? Then the second phase will be the network design decisions, right? So in the first phase, we have seen what is the distribution and what are the factors will affect the distribution network. And third one is the what is the design options, what are the design options are there. Then the impact of the online sales, the impact on the online sales in practice, that we have seen, right? Then the second phase, the network design decisions, then the factors affecting the network design decisions, then the framework, and this model, right? So these are the topics will be covered in the unit 2, right? So in this unit 2, do you have any doubt? Do you have any doubt? So up to this, your second unit will be gets over. Do you have any doubt? Anyone? No. Okay. Sivasanman sir. Okay, right. So the attendance will be posted in chat box.